Here we're going to consider two experiments, and that is what will help us to really understand the concentration of reactants. So consider the following before we look at those experiments. The stomach contains hydrochloric acid, which is a very corrosive acid. A piece of burning charcoal burns with a bright flame when lowered into a gas jar of oxygen. Oxygen rekindles a glowing splint. I want you to consider those instances. Magnesium reacts faster with an acid as the concentration of the acid is increased. The general conclusion from the above observation we have mentioned is that they are considering what we call concentration of reactants that depend on what is known as number of collisions. And that is what you want to discuss in this lesson. Our first experiment, experiment 1. You want to look at reaction between magnesium ribbon and hydrochloric acid. Procedure. Take 4 conical flasks labeled A, B, C, and D. Measure 40 cubic centimeters. Of 2 molar HCl and transfer into conical flask A. Into flask B, C, and D, transfer or place 30 cubic centimeters in B, 20 cubic centimeters in C, and 10 cubic centimeters in D of the same molarity, same acid. Dilute the acids in flask B. Dilute in C and in D, whereby in B we dilute with 10 cubic centimeters of distilled water, 20 cubic centimeters of distilled water for C, and 30 cubic centimeters of distilled water for D, that is flask D. What you're trying to say is that the volume is to 40. So when we have 30, we add 10. When we have 20, we add 20. And finally, where we have 10 cubic centimeters of the acid, we add 30 cubic centimeters of distilled water. The next procedure, drop 2 centimeter long magnesium ribbon that is clean. Into flask A and immediately start the stopwatch. Note the time taken for magnesium ribbon in the flask to be completely used up. And during that, we shall really observe production of the gas. That's a possible way to use to tell the rate of reaction. Now, it is clear that of all the flask, or if we use boiling tubes, there's a reaction that is going to take place, and the magnesium ribbon will react with the hydrochloric acid, and from that reaction there is production of a metal salt, and hydrogen gas will be evolved. So this is the kind of reaction that will take place in all the conical flask or boiling tube for that matter. So we have, this is the magnesium ribbon. Then these are bubbles of a gas, of which there is that boiling tube or conical flask that will have a faster reaction compared to the other. Let us look at the experimental results that is able to tell us the effect of concentration on the rate of reaction. So results. Now we have 4 conical flask. There is A, B, C, and D. So our first one is flask. Volume of acid, obviously in cubic centimeters. Volume of water. After that, we have what we call concentration of HCl, time taken. Then we'll have 1/T. So this is the result in a table. Time is in seconds. That is test tube A, test tube B, C, and then finally we have test tube D. The last test tube, that is test tube D. So this is the table from that given experiment. So we have test tube A or flask A, flask B, C, and D. Volume the acid 40 cubic centimeters for the first one. We use 30, 20, and then 10 cubic centimeters. On addition, this was addition of 30, addition of 20, 10 cubic centimeters, and 0 cubic centimeters. So molarity there is just 2 molar for the first one. Second one, 1.5, 1, 0.5. Time taken for the evolution of a gas. If you want to calculate anyway this molarity, maybe those who do not know how we are getting 1.5 molar, 1 molar, 0.5 molar. We use the formula C1 V1 is equals to C2 V2. Recall our topic moles in Form 3 work. So when we have C1 is where we had like 2 molar. I want us to continue with our first factor affecting rate of reaction, that is concentration of reactants. Where we were trying to explain the changes in the concentration of HCl, that is coming up with 1.5 molar, 1 molar, and 0.5 molar. And we said that is a matter of using the formula C1 V1 equals C2 V2. Maybe to explain how we are getting the 1.5. That is what you want to illustrate and explain down here. And then we shall move to the record of time for that given reaction. Now, our C1 is 2 molar. V1 is 30 cubic centimeters before the dilution. Our C2, we don't know, times V2 is now 40 cubic centimeters. Remember, some 10 cubic centimeters of water has been added. To get now the new concentration, we divide through by 40 cubic centimeters. That and that vanishes. Divide that by 40 cubic centimeters. 2 ones, 2, 2. 3 over 2, which is 1.5 molar. So that is how we come up with the 1.5 molar for the content in flask B. Now, time taken for the first reaction was recorded to be 20.3, 55.69, 131.53, 625.03. 1 over T, this will give 0.0016. The next one will give 0.007603. Then the third one over T will be 0.01796. And finally, 1 over 20.3 will be 0.04926. That is the new record of 1 over t. Experiment 2. Then we'll make a general conclusion. Here we want to look at reaction between sodium thiosulfate and sulfuric 6 acid. Procedure. Again, we want to use the 4 conical flask. Take 4 conical flask and label them A, B, C, and D. Measure 50 cubic centimeters of sodium thiosulfate and transfer in flask A. Into flask B, C, and D, place 40 cubic centimeters B, in C 30 cubic centimeters, and in D place 20 cubic centimeters of the same thiosulfate. Dilute the thiosulfate in flask B using 10 cubic centimeters of distilled water, in C 20 cubic centimeters of distilled water, and in D we dilute using 30 cubic centimeters of the same distilled water. Mark X on a white paper and place flask A with its contents on the piece of paper. White paper and place flask A. On the paper. Measure 10 cubic centimeters of 2 molar sulfuric 6 acid and add to the contents of flask A and start a stopwatch immediately. Start the stopwatch. Look through the flask and record the time taken for the cross on the paper to disappear, to obscure, to be invisible. Observe the disappearance of X. Now, the reaction will repeat the procedure with flask B, C, and D, and then we again have the experimental results. So it is clear that sodium thiosulfate will react with sulfuric 6 acid, and as a result of that reaction, there will be observation of some yellow solid of sulfur. So this is the kind of reaction that will take place, and this is what is going to be observed. At the start, if you look, you'll be able to see the X, the cross, but eventually after formation of sulfur precipitate, which is yellow, then you will not be able to observe the cross. So that shows that at that given moment, the reaction is over. So we can use now that observation. This is now a matter of color observation. How long does it take for precipitate to be formed that we cannot now see the cross that was visible before? And that is all what we contain, or what contains reaction rate depending on concentration. The experimental result will be as follows. The result this is the table containing the results. So we have flask, volume of sodium thiosulfate in cubic centimeters, volume of water added also in cubic centimeters, concentration of sodium thiosulfate, then time taken in seconds, time taken for X to disappear, then finally 1/T. save that. So that is flask A, flask B, C, and finally flask D. So those are the 4 conical flasks that we have. That is that. So to record the results, we have flask A, that one, flask B, C, and D. This one has 50 cubic centimeters. This one has 40, 30, 20 added, nothing added, 10 cubic centimeters added, 20, 30. The molarity started with 0.15 molar. Then with the same calculation of C1V1 equals C2V2, we get this to be 0.12 molar. This is 0.09 molar, 0.06 molar. Time taken 21.06, 25.5, 33.6, 54.68. Then 1 over t, the inverse of time. The first one is that is 0.04748. Then we have 1 over 25, 1 over 25.5. That gives 0.03922. Then 1 over 33.6, 1 over 33.6, that is 0.02976. Finally, 1 over 54.68, 1 over 54.68. That gives 0.01829. From this, that is the 2 experiment. Shortest time was taken for the experiment in S. When concentration was lowered, the time taken for the reaction to completion also increased. So, that is enough to tell us that the rate of reaction increases with the increase in concentration. Of the reactants. You can see that in case 1, when the concentration of the acid was 2 molar, then it took very short time for reaction to end, meaning there is a high concentration and therefore the rate of reaction is also higher. That's why it takes short time to reach completion. As the concentration, maybe to explain this, as the concentration increases, as the concentration increases, the number of the reacting molecules increases. This increases collations, the number of collations, resulting into an increase rate or an increased rate of reaction. We are saying that when the concentration increases, the number of reacting molecules will also increase. There will be more molecules to react. Then, because of that, there is going to be somehow more collision between the reacting particles. And when they collide, they end up reacting very fast. So because of that more collision between the reacting particles, we end up with a reaction that is faster. So when the particles are close to one another, they collide vigorously. And as they collide, they react. And that is why the rate of reaction fully depends on the collision of the reacting particles. And we have said that collision of the reacting particles is as a result of what we call increased concentration. Now we have realized that in a case where a magnesium is reacting with, we have talked of magnesium reacts with what we call hydrochloric acid, and we have realized that reaction is able to give us what we call magnesium chloride and hydrogen gas. And it's this production of hydrogen gas that is able to tell that reaction is to completion. So remember, when we were just starting this factor, we talked of the possible ways that we can use to determine that a given reaction has taken place, or a reaction has